In this lesson, we'll be looking at solving inequalities symbolically. Our objectives will be to use the addition and multiplication properties to solve an inequality symbolically, and to review the three ways to write the answer to an inequality. So let's begin by solving an inequality. Let's start with a very simple one here. I have negative 2x plus 5 is less than or equal to 15. Now, if this were an equation, you would tell me to subtract 5 from both sides. And it turns out with the inequality that the steps are exactly the same, with one exception. Anytime you multiply or divide an inequality by a negative number, the sense of the inequality changes. Let me say that one more time. If you multiply or divide by a negative number, the sense of the inequality changes. And what that means is that if it's a less than, it becomes a greater than. If it's a greater than, it becomes a less than. And that happens anytime you multiply or divide by a negative number. So let's continue solving here. We said we wanted to subtract 5 from both sides, and so let's do that. That leaves me then with a negative 2x is less than or equal to 10. The next words out of your mouth should be, I need to divide both sides by a negative 2. And the minute you say the words divide by a negative, you know that the sense of the inequality should change. Some of you will say, I need to flip the symbol. And that's exactly what I'm going to do. I have a negative 2x divided by negative 2 is greater than or equal to now 10 divided by negative 2. On the left-hand side then I get x is greater than or equal to a negative 5. Now I want to remind you, we said we wanted to also review the three ways to write an inequality. Let's remember first of all that we can graph it on a number line. So let's do that. Since we have x is greater than or equal to a negative 5, I'll come right here, and some of you will tell me to put a solid dot there. It's a solid dot because it is a greater than or equal to. And then you would tell me to shade, hopefully to the right, since that's where greater thans are. How far will it continue to be shaded? To infinity, and you may want to write that out there because I think that'll help you when we get to the next step we need to do. I also want to remind you that in this text they will use the square bracket, the same place we would use a closed circle. So our number line would look like this. Next we have set builder notation. And set builder notation looks like this. We simply have the set brackets, and it says the set of all x's such that x is greater than or equal to 5. Now let me break that down for you. This symbol right here says I have a set. So if I read this in math, here's what it says. The set of all x's, and then this line right here says such that. If you're reading this in math, you would read the set of all x's such that, and then you describe what they are. And it's always just a matter of picking up this piece right here and plugging it in here. Close your set bracket and you're done. So let me read that to you now that it's complete. It's the set of all x's such that x is greater than or equal to a negative 5. And then the last thing we need to do is write that in interval notation. Now we've done interval notation before, so let's see if you can remember. I think it's helpful to you if you'll look back up here at your number line. So the interval notation would be open bracket negative 5. The interval continues all the way to positive infinity, and remember you always have a parenthesis next to an infinity symbol. So now we have solved an inequality and written the solution in three different ways. Let's do another one. We'll make this one a little bit harder, and if I were you, I would pause the video and do this one, and then check our answer at the end. Remember, I'm going to ask you to write your answer in all three ways. If we distribute here, we would get negative 6x plus 15 is less than 10 minus x minus 5. Now these steps are nothing new. We should be able to do that. Our next step would be to combine like terms on this side. So let's do that. And I get negative 6x plus 15 is less than negative x plus 5. Next, if we subtract 15 from both sides, we get negative 6x is less than negative x minus 10. We would then want to add x to both sides, and we would get negative 5x is less than negative 10. Then I want you to be careful on this next step, because this is where you're going to tell me to divide both sides by a negative 5. And when you do, you've got to be aware that this right here became a greater than. The minute you said divide by -5, it became x is greater than, and then a -10 divided by -5 is a +2. We still want to write this in 3 different ways, so let's graph it on a number line. This time it would be an open circle at 2, or you could think of it as a parentheses, and it would shade once again to the right. How far? To positive infinity. In set builder notation, it would be the set of all x's such that x is greater than 2. Remember, it's just a matter of picking this piece right here up and plopping it right in there. And then our last thing will be to write interval notation. Once again, the easiest way to do that is from the number line. It would be open parentheses, 2, all the way to positive infinity, close parentheses. Let's look at one more. I would suggest at this point that you pause the video and work this one and write your answer in all 3 ways. I would get 6x plus 15 is less than or equal to 9 minus 2x minus 10. Once again, let's combine the things over here that we can. So that would be these two. So I would have 6x plus 15 is less than -2x minus 1. Let's subtract 15 from both sides, so I have 6x is less than or equal to a -2x minus 16. Add 2x to both sides, and I get 8x is less than or equal to a -16. And let me ask you, what is your next step? Divide both sides by 8. Does the sign flip or not? Well, when we divide by a +8, the sign does not flip. And the reason I've given you this one is I want you to notice this sign has nothing to do with whether or not it flips. It's the sign of the number that you're dividing by. So in this case, you would have been dividing by a +8 and by a +8. Therefore, the symbol does not flip, and we get x is less than or equal to a -2. Now let's write this one all 3 ways. If I want to draw it on a number line, it would be a solid circle at -2, or a square bracket, and it would shade which way this time? Less than, so it would shade to the left. How far did that go? To -infinity. And if you'll write that -infinity out there, I think it'll help you on the next thing we need to do. Let's look now at set builder notation. It's the set of all x's such that x is less than or equal to -2. And now we want to do interval notation. It'll be open parentheses, -infinity, comma, -2, and the square bracket because it is a less than or equal to, and the closed circle. I think most of you will like this section okay. We've already done interval notation, so that should come back to you pretty quickly. And the steps on solving inequalities are just like the steps for solving equations, with that one exception of when you divide by a negative number. So I want to leave you with a thought. Man is the only animal that blushes, or needs to. I'm proud to be a person that at my age can still occasionally blush. I'll talk to you later. Bye-bye.